Hello, Stat 300. This is Professor Gonzalez, and I'd like to take a look at some problems from homework section 6.2. Now, this is on the assignment side of Alex, and we're taking a look at probability as it pertains to binomial problems. Okay, so let's take a look at this first problem, and we already did. If you have taken a look at 6.2 on the adaptive side of Alex, I kind of went through some of that a little bit. Let's go ahead and jump into one of these problems, actually a couple of the problems, and talk about the formula as we do this. First, question number 1 says determine whether the random variable x has a binomial distribution. If it does, state the number of trial n's, or the trials n rather. If it does not, explain why not. Okay, well, here's the problem. It says a coin is flipped until a heads appears. Let x be the number of heads. So a lot of this sounds really good for a binomial distribution because when you flip a coin, you have there's two possibilities, right? A heads or tails, so that's the binomial part. Also, the probability to get a heads and the probability to get tails is the same each time, right? So that probability doesn't change. And also, when you flip coin number 1 and flip coin number 2, they are independent from each other. So that is also satisfying this situation. But there is a little bit of a problem. The problem is, so first of all, we're going to say, is the random variable a binomial distribution? We're going to say the random variable is not a binomial distribution. And why? Because the number of trials is not fixed. Well, how do we know the number of trials is not fixed? What did they say? A coin is flipped until a head appears. Well, I don't know if the first head is going to appear on the first trial, or is it going to appear on the 10th trial? That'd be pretty unlikely for it to appear on the 10th trial, but it could happen. So anyhow, the number of trials n is not a fixed number, and so therefore it cannot be a binomial distribution. Okay, so that was problem number 1, part 1 and part 2. Let's take a look at number 2. Now number 2 has parts A through D, so it's kind of long. Let's start off with part 1 of 2. It says find the probability that exactly 4 of them fail. Oh, what's the particular problem here? It says car inspection. Of all the registered automobiles in a city, 6% fail the emissions test. 13 automobiles are selected at random to undergo an emissions test. Round the answer to the nearest 4 decimal places. Okay, well, first of all, that sounds good. They've got 13 cars are going to be selected, so let's just start by saying the number of trials n is 13. Part A, find the probability that exactly 4 of them fail. So it's a little bit strange, but remember how P is going to be our successes? Well, since we're testing for failures, then P is going to be the failures, right? Because we're testing for failures of this auto emission, a car inspection, right? So we're looking for failures. So that means our p-value is going to be 0.06 or 6%. Well, we know with a binomial distribution, the p-value and the q-value are going to be complements. So therefore, the q-value must be 0.94. Okay, we got number of trials, we got a p-value, got a q-value. In this particular problem, they're asking to find the probability that exactly 4 of them fail. So now we have our x value, x equals 4 as the number of successes, but in the context of this problem, I think I'm going to write that down. In the context of this problem, a p-value, which is normally a success, is going to be, in this context of this problem, it's failing an emissions test, failing the test. So don't let that mess you up, hopefully. Once again, the probability of exactly 4 of them failing a test. So we're testing for failing, and so when they fail, it's a success in the formula. It's a little weird. So anyhow, let's go ahead and set this formula up. Now, if you remember the formula, we're going to call this P of 4. It has a combination piece to that. I'll talk about that. I remember talking about that on the last one, but let's talk about it again. It's a combination of 13, choose 4. Now the 13 comes from 13 trials, and 4 is because it says exactly 4 of them fail. Now exactly 4 of them is kind of a key thing. And the next one shows the difference. It's not exactly, so we'll see how we actually tackle that problem. So we got the combination of 13 choose 4. Now the next variable that needs to be filled in is going to be the probability P, the probability of success, in this case failing the test, which is 0.06. And how many are going to fail the test? Well, it says we want exactly 4 of them to fail, so that's going to be raised to the 4th power. And then, of course, passing the test is going to be its complement, 0.94. And how many are going to pass the test? Well, we have 13 trials, 4 of them failed the test, so that means the rest of them passed the test, so that must be 9. Okay, so let me go ahead and show how to figure out this combination by hand. Let's do that up here. So remember what that formula is. It's going to be the combination of 13 choose 4. That's going to equal 13 factorial up top over 4 factorial down below times 13 minus 4 factorial. Let's simplify that a little bit. We've got 13 factorial over 4 factorial. 13 minus 4 gives us 9 factorial. Okay, so let's see. We'll put a little extra dot there. There we go. Okay, so now let's see, how does this simplify factorials, right? We'd like to line up common factorials. So we've got 13. I'm going to write 13 factorials. 13 times 12 times 11 times 10 times 9 factorial. And if I write it that way, it perfectly matches up with the 9 factorial in the denominator. We still have 4 factorial, which is 4 times 3 times 2. So these are fractions. In fractions, we get to reduce common factors, and 9 factorial over 9 factorial will reduce perfectly. We can continue to reduce if we want, or we can multiply the numerator and divide by the product of the denominator. That's fine. I can't help myself because I see 4 times 3 is 12, and there's a 12 up top. So those will really reduce perfectly. And while I'm at it, I might as well just finish up and do more reducing here instead of just use a calculator. And I see 2 reduces, so 2 goes into 2 once and 2 goes into 10 5 times. Now the problem with all this reducing is it gets so sloppy you might actually miss something, right? But we've reduced the denominator down to 1. And the top, what do we have left? I see 13 times 11 times 5. Maybe I'll use a calculator. Give my brain a rest here. And let's see, 13 times 11 times 5. I'm coming up with 715. 715. So that part of the formula right there, we figured out is 715. And then we need to multiply it by 600ths, or 0.06 raised to the 4th power. And of course, you can use your calculator at home, or you can use the calculator within the ALEKS program. When I multiply all of this, I get approximately 0.00, let's see, 0.005, and then 3095. It says to please round this to the nearest something. Where is it at? Nearest 4. Where did it go? Please round the answer to the nearest 4 decimal places. So we go over to the 1, 2, 3, 4th place. Look at that digit to the right. Yep, it is smaller than 5. Anyhow, so we end up with rounded to 0.0053. And that's the probability that we're going to get exactly 4 of them, those 4 of the 13 cars, to fail the test. And that's not very likely, right? No, not very likely. Okay, let's see. I think I want to talk about this a little bit. These parts. Let me go ahead and highlight this piece right here. And I did this last time also, but I think this could kind of be insightful, maybe help understand a bit. So what's going on here, and actually I don't have a lot of space to work, unfortunately, but let me maybe zoom in here. So what's happened here is we've got how many? 13? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We've got 13 cars that need to be checked, and we're saying we want exactly 4 of them to fail. So, you know, you could have a fail here. I mean, one of the possibilities, right, is going to be a fail, fail. There's 4 of them. So that's 4 of them. So then the rest of them are going to be passes. Right, so you're going to figure out that if you're trying to find the probability of this, it's going to be the probability to fail times, raise the 4th power. So the probability to fail, I'll just write under there. Remember, it was 0.0, what was it, 0.06, I believe. So that's where that comes from, right? 0.06 raised to the 4th because we have 4 of them. And the probability to pass was its complement, 0.94. And we have how many of those? 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. And so there's that in the formula, right? There's that piece in the formula. So let me use a little more color maybe to show that. So this part right here of the formula comes from the fact that we have 4 of these. It won't highlight. Interesting. Comes from the fact, it doesn't highlight because I actually used the eraser thing. Anyway, so it comes from the fact that we have 4 of them. So we have 0.06 raised to the 4th power. And then this piece over here, green, this piece over here, comes from this part of the problem because we have 0.94, and how many of them do we have? We have 9 of them, so raised to the 9th power. So the big question I'm trying to settle right now is where is this 715 coming from? And of course, I did the color coordinating that combination of 13, choose 4, so we can see that's where it came from, right, in the formula. But what's actually happening with this problem? What's happening with this problem is this fail, 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 and then pass, 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 pass. That's just one possible way of grouping these things, right? I mean, there's so many of them out there. In fact, let's see, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so how many different ways can we group this? Well, it could be a fail, and then pass, fail, pass, fail. How many fails are we supposed to have? 1, 2, 3, pass, fail. So we have to have 1, 2, 3, exactly 4 fails, right? And so the rest of these would be passes. So it's kind of mind-blowing that, wait, we have to keep track of all these things, right? But if you look at this, it doesn't really matter of the grouping in terms of this part, right? In terms of this 0.06 to the 4th power, that's going to happen on each, whoops, I'd used the wrong highlighter, that didn't work at all. It's going to happen, look at that, fail right there. That's, for some reason I can't write on it. Maybe if I circle it, there we go, circles work. Fail, 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 fail. We still have 4 fails, which is still going to give us this over here, which is 0.06 to the 4th power. And we still have what? We still have, darn it, what color did I use? Green. We still have 1, 2, 3, 4, 5, 6. This thing's not working on me. 6, 7, 8, 9. We still have 9 passes. So it doesn't matter how I group this, I'm always going to get raised to the 4th power, so 0.06 raised to the 4th power, and 0.94 raised to the 9th power every single time. So now it comes to how many of those am I going to have? And yes, you guessed it, what calculates that is this combination of 13, choose 4. It's that we have 715 of these different arrangements. I only showed you, not arrangements, that's the wrong word, groupings. I only showed you 2, right? So it'd be really, really hard to do this by hand, finding 7. You probably missed a couple, right? So that's what's going on there. That's, we'd continue, if we're trying to do this by hand, we'd continue doing this, and you'd go all the way down here, having 715 of them, go, oh, there's 715 different ways to group that, and so I need to multiply by 715. That's not reasonable, so we use this combination of 13, choose 4. So some really nice formulas do a lot of work for us. Okay, so I went into lots of detail on that, hopefully not too much. Let's take a look at the next one. Now, the next one is a little nasty, really, and it's really asking for a little too much for us to be doing this by hand, really. We're kind of on the edge of kind of insanity, I think, on this one. But this one says, so I'm gonna show you. It says find, so you know, some with probability and statistics, you could have some problems you can calculate by hand, which I think is really good for understanding. But then when the numbers and the data size and the stuff gets so large, it gets crazy. And this is kind of getting there. But anyways, here it goes. Find the probability that fewer than 4 of them fail the test. Okay, so last one was exactly 4, right? Exactly 4. So if we want to know fewer than 4, I'm going to do this little number line. Now remember, this is discrete going on here because we're talking about cars passing and failing. That's discrete, right? Because you can't have 5.25 cars passing the test. So these are discrete. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 cars. I don't know why I have to do every single one of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I just felt like I had to write all of them down there. Now it says find the probability that fewer than 4. So that does not include 4. Fewer than 4. That's 3, and that's 2, and that's 1, and that's 0. So what are we looking for again? This is showing, this model is showing me that I want the probability that fewer than 4 cars, or fewer than 4 of them, fail the test. Well, this might not be super obvious, but what this means, and here's the nasty part, this means we have to calculate, we have to calculate the probability of each one of those. So remember the last one we said find the probability of exactly 4? Well, when they say fewer than 4, it means find the probability of 0 fails, find the probability of 1 fail, so I'm going right down my list. My goodness, I can't speak. Find the probability of 2 that fail, that's that guy. And finally, find the probability of 3 fail. Wow, so now the process we just did must be done 4 times. Now I can go a little bit quicker because I don't have to explain all this over here, right? You just use the formula. But like I said, Microsoft Excel has formulas for this. The TI-84 and the 84 Plus and all that has formulas for this too. So this gets a little bit much here, but let me go ahead and show it to you. Remember the formula? It's going to be now, the x value is 0 when you say p of 0. The x value is 1 when you say p of 1, and so on. Now remember the same things hold true from the last problem. And that is the probability that they fail is still 0.06. The probability that they pass is still 0.94. All right, so to do this particular problem right here, and let me see if I could use braces or something, it's going to be combination of 13 choose 0 times, remember it's going to be the probability that they fail, which is 0.06, and we want 0 fails on when their x value is 0. That means now the probability of the passing is 0.94, and if we have 13 trials and 0 fail, that means 13 pass. Okay, so you're going to see this sort of balancing act. The exponents, 0 plus 13 must equal our total number of trials, right? That's going to happen each time. The next one is a probability that exactly 1 fails. Okay, well, that's going to be a combination of 13, choose 1. Now it's going to be times the probability of failing is 0.06, and there's 1 of them that fail. That if 1 fails, that means now probability of passing is 0.94. How many pass? If we have 13 that try, 1 fails, that means that 12 must be passing. Okay, now we're moving along. So you can see, let's see if you can see, let me use some color to highlight what I'm doing here. I think you probably can see it. The probability that 0 fail is going to be calculated by that. The probability that 1 fails is going to be calculated by that, and so on. So let me do the next one. The probability that exactly 2 fail, well, that's going to be a combination of 13 choose 2. We've got the probability of failure is 0.06. How many are failing this time? 2, because probability of 2, right? And then we've got the probability of passing is 0.94. If 2 fail, that must mean out of 13, the remaining 11 must be passing. And now we're down to our last one. The probability of P of 3, that's the probability that exactly 3 fail. That's going to be the combination of 13. By the way, I'm not going to make you do this on a test because you don't have a calculator, or you do have a calculator, but we're doing it by hand. So really, realistically, doing it by hand, you're just going to be doing one of these just to put you at ease. So we've got the combination of 13, choose 3. Now the probability that you have a failure is 0.06, and I've got 3 of these failures on this last one, and 0.94 is passing, the probability of passing, and I must have 10 of those on the last one. Now let me use my red color also to show that the probability that 2 fail is calculated by this in the bracket, and the probability that exactly 3 fail is by that in the bracket. So each one of those must be calculated and added up. And so I went ahead and did that for us. And so when we calculate this piece right here, I wrote this down on a nice little piece of paper, 0.447365 approximately. Plus the next is calculated to be 0.371218. And the next is calculated to be 0.142169. And finally, the last term to be calculated is 0.033273. Okay, when I sum all that up, I end up getting approximately, of course I'm going to sum all these up, I'm going to get approximately 0.994025. My kids make fun of my 9s, and so I will fix that 9 before anybody sees that sloppy little 9 that I seem to make on a regular basis. So now we've got 0.994025 approximately. I believe it said to round to, let me go back. What does it say to round to? I believe it said round to 4 decimal places. So we will go ahead and round to 1, 2, 3, 4 decimal places. So this is going to be approximately 0.9, there's that 9 again, 9940. So the probability that you're gonna, okay, so it says the probability that fewer than 4 of them fail the test is calculated, and it's pretty high, right? 99.4%. Pretty high chance that fewer than 4 of them are going to fail. Okay, let's move on. And here we are. It says, find the probability that more than 3 of them are going to fail. Now this is sounding really bad. Let's make a little visual model of what's happening here. You've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So this is saying find the probability that more than 3. So here's 3, more than 3 of them fail. Must be 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh my gosh, are we going to have to do this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times? The last problem was already a nasty nightmare, and we did it 1, 2, 3, 4 times. Now we got to do it. Okay, actually no, because what we found here, let me see if I can highlight this with some color. What we found here is the probability that fewer than 4 of them fail. So we found this right here, right? That's what we just found. So let's see. We found 0, exactly 0, 1, 2, and 3. That's what we found, right? But look at the complement of what I'm looking for. So that's what we found on the last problem. I want the complement of that. So the way to do this without going super crazy, is, and let's do our work right here since I've got space. Basically, I'm looking for the probability of this random variable x being greater than or equal to 4. That's one way to say it, right? So all of them, 4, 5, 6, 7, up there. But I already know the complement. So the easier way to do it is say, if I just take 1 minus the green stuff, let me do that in green. If I say 1 minus the green stuff, and what was the green stuff? The green stuff is what we just found out. That was, let me write it in a maybe an easier way to say C. And the green stuff was what we just did in the last problem, which was the probability of 0, exactly 0 rather, plus the probability of exactly 1, plus the probability of exactly 2, plus the probability of exactly 3. That's the green stuff, and we know the answer to the green stuff, right? So now we can actually do this problem without having to pull out that formula and do all that heavy lifting. Let's see. What was the answer to the last problem? Well, it was 0.994. 0.994. And so that makes this problem much easier because that was given to us. So if we subtract that out, 1 minus 0.994, we get, where am I at? We get 0.006. Okay, so was that it there? Let's see. Yeah, okay, so that's number 3. Let me put a number 3 here. So now we need to do number 4. I'm going to go down here with number 4. Number 4 said, would it be unusual for none of them to fail the test? Okay, so the probability of none of them is P of 0. And if we went to calculate that, remember that would be the combination of 13, choose 0. That would be, what's the probability of failing? That's 0.06. If none of them fail, that's a 0. That means the rest of them at a probability of 0.94 pass. And we could go ahead and calculate that. That's only one of them. That's no big deal. But you know, we did do the work already. Remember? Remember in this big nasty problem? This part right here, I'm going to make it pink. This part right here is a probability that 0 fail, which was this number right here. So it's already calculated for us, 0.44. If we do it to 2, let's see, they said do it to round to 4 decimal places. So that is just 0.4473. 0.4473. Zero 0.4473. So the probability that exactly 0 of them fail is 0.4473. Now the question, the follow-up question I believe says, it, and then you got to do the pull down menu, it blank be unusual for none of them to fail the test since the probability is, okay, you got to love this fill in the blank stuff. I didn't even look at that. See, it would not, let's see, let me think about this. Okay, let me tell you what I'm thinking here. The probability that exactly 0 of them fail is 0.44, which is, pretty much 44.7%. Now, in statistics, as a general rule of thumb, if you're going to say something is unusual, and that's the word they use, unusual happens when something is 5% or less. Well, this is 44%, so this is not unusual. This is not unusual, so that's what we're going for. So it would, I don't know what the pull down menu is because this is just a PDF, but it would not be unusual for none of them to fail the test since, why? Because the probability is 0.44, what was it again? 4473. For us to say it would be unusual, the probability would have to be less, or 5% or less, so that'd be 0.05 or less. And that's not the case. This is at 44% about, right? A little more than 44%. So this is not unusual. All right, we have completed the problems from this part of ALEKS. Let's see, what section was this again? This was 6.2. I hope this helped, and we will talk to you soon. Thank you. Take care. Bye.